So here's an example for our series of collisions. We have, suppose a gangster sprays Superman's chest with 3-gram bullets at a rate of 100 bullets per minute, and the speed of each bullet is 500 meters per second. Suppose, too, that the bullets rebound straight back with no change in speed. What is the magnitude of the average force on Superman's chest? So let's write down our givens first. So we know that the bullets have a mass of 3 grams, which of course is 3 divided by 1,000, which is what, 0.003? 0.003 kilograms. And then it tells us that they're at a rate of 100 bullets per minute. Now that's going to mean something, but I'm just going to write that down for now. And of course, we don't want minutes in physics, we want seconds. So I'm just going to convert that to bullets per second as well. So 100 bullets per minute, and then there's 1 minute, 60 seconds in a minute. So this ends up being 1.67 bullets per second. Okay, and then it says the speed of each bullet is 500 meters per second. So initial velocity is a positive 500 meters per second. And then the bullets rebound straight back with no change in speed. So that means they're going at a positive 500 meters per second. And then we have a negative 500 meters per second for our final velocity. Okay, we want to know the magnitude of the average force on Superman's chest. So what we just learned from our series of collisions video is that the average force from a series of collisions is equal to a negative N over delta T times our mass times a change in velocity. And remember, this is taken from our force is equal to change in momentum over time. But of course, now we have a number of particles. So we have that N times change in momentum, N times mass times change in velocity over time. So remember the rate, so they gave us 100 bullets per minute, which we converted to 1.67 bullets per second. That is this number right here, our N over delta T. So this is the rate of those projectiles. We're also given the mass of the bullets, and we're given our initial and final velocity. So now we can just plug everything in order to find our average force. So force is equal to a negative 1.67 bullets per second times the mass, which is 0.003 kilograms, times change in velocity, which is a final velocity, negative 500 meters per second, minus initial velocity, 500 meters per second. So here we get that the average force will be equal to a negative 1.67 times 0.003 times the quantity, negative 500 minus 500, and we end up getting that the average force is equal to 5.01 newtons on Superman's chest from those bullets.